Hello, hello, hello. This is Mr. Keeney here for section 1.3 day 2 notes, or just distance formula. No face cam today, too much memory being used on the iPad. So I'm going to be going over notes for the distance formula. So learning targets, I just want to make sure we go over them. We're still building off of our vocabulary of the undefined terms. So the undefined terms, point, line, plane, we're still developing those, and we've made other connections, and we've gone through the segment addition postulate, midpoint formula, and today is going to be all about the distance formula. I'm not sure why it's formatted that way, but that's okay. So we're really just going to get right into it here. The distance formula, if A and B, which those are points on our graph here, our coordinate plane, the distance between those points is, and so before I just give it to you, I'd like to take a second to kind of develop what's going on here. So this is the segment, oh wow, that is not even close to being here. I'll use the highlighter for this. This is the segment I want you to be concerned about. That is the segment AB with coordinates x1, y1 for A and x2, y2 for B. We are trying to find the length of that. So what we've done here, and you probably can see these things down here. You have this, and you have this, and you have a point C. And I just want to explain what is happening. What is happening is I have made us, or you are going to make this for yourself, a right triangle. Those right there give us a right triangle. And this is very important because we've learned something about the right triangle, or you have, I'm assuming have. It's called our good friend, the Pythagorean theorem. Now, the Pythagorean theorem says c squared is equal to a squared plus b squared. You might be used to seeing a squared plus b squared equals c squared. That is the same thing. I just use the symmetric property to flip sides. So I want you to think, well, if this is A and this is B, and this is C, I can use this formula here to develop another one. Really, the distance formula is just derived from the Pythagorean theorem. So let's jump into it. I'm going to change colors here, a nice red. If I'm looking at c squared, I have no idea what that is. That is just segment AB. So AB squared, that is what we're trying to find. That's kind of the end goal. Now, if I look down here at A is x2 minus x1. So I'm going to go ahead and substitute that in for A. And how I'm getting that, just to make sure you know, this is A, and it says it's x2 minus x1, the absolute value of x2 minus x1. So I'm going to say x2 minus x1, x2 and x1 being coordinates of our points. And similarly, B is y2 minus y1, the difference of our vertical coordinates. So I'm going to substitute that in as well. So instead of B, oh, the wrong thing. Instead of B, I'm going to put y2 minus y1. So what can we get from this? Well, if I'm trying to find the length of AB, remember, I'm trying to get AB here. I'm really close to getting AB isolated by itself. So close, in fact, that all I need to do is get rid of this pesky squared. And kind of what you've learned, I think, in Algebra 1, even before that, is I can cancel out, if you will. I can get rid of, I can simplify, whatever word you want to say. But basically, this squared, I can square root both sides, and I'll be left with a B, because the square root of something squared is just itself. Now the problem is, if I do that, I can't just square root the left side of the equation. I've got to square root the other side. Now this right here is our distance formula. X squared, x2 minus x1 squared plus y2 minus y1 squared, and all of this is underneath the radical. So that is our distance formula, and I will go ahead and make sure you're following along, putting these in your own notes as well. So if I wanted to find the distance of a segment, I would take the difference of the x coordinates, square them, add them to the difference of the y coordinates, that are squared, and then I would take the square root of that. So that is our distance formula, and I'm going to go ahead and box it in because it's beautiful. This would be something to memorize. It would be helpful. It will not be given, if you were in class, it would something that would not be given on the test. Obviously, this year with our virtual learning, that might look a little bit different. So we're going to try to take that for our first example. Now I'm going to try to show you two different ways. Let me scroll down. Yeah, I'm going to try to show you two different ways for this one. One using straight up the distance formula, another using the Pythagorean theorem, which is really the same method we talked about, just different ways to approach the problem. So it wants the approximate length of RT. So they want the distance from point R to point T. So RT is equal to, and here's our distance formula. We have x2 minus x1 squared plus y2 minus y1 squared. So another helpful thing for me, at least, I like to go up here and say there's my x1, there's my y1, here's my x2, here's my y2. Not something that you have to do. I would highly recommend it. For me, it ensures that I'm getting all of my labeling correct. So RT is equal to, and I'm going to go ahead and I call it putting in my blanks here, because all I'm doing is I'm substituting in values using my points. So let me switch back to the red. So for x2, I look at what I labeled. It's -4, so I'll put -4. For x1, I got 3. And I'm just getting these again. I'm getting them from up here, just so you know where I'm getting them from. And then y2 would be 3. And y1 would be 2. All right. So now that I've substituted in those values, we are going to do some simplification ourselves. So RT is equal to, we got the square roots. -4 minus 3 is -7 squared, plus 3 minus 2 is 1 squared. All right. And then we're going to keep going. So RT is equal to -7 squared is 49 plus 1 squared is 1. And then I'm going to go this way. 49 plus 1 is 50. So now here, let's talk about what we want to do for our final answer. So we're here, and really you're going to have a couple options. For right now, I'm going to allow you to choose your favorite one to put your final answer. I'll have both, but I do want to make sure you can put your answers in terms of radical form and decimal form. So if I were to put this in a calculator, the square root of 50 is approximately 7.07, and then we're going to put units as well, because we always got units. So that is a possible answer. Also, the radical form of this, so if I wanted to get the radical form, square root of 50, I know that that is the square root of 25 times 2, because 25 times 2 is 50, and the square root of 25 is 5, and that 2 stays underneath. So 5 radical 2 units. This is something that we might go over together, so something that if you want more help on simplifying radicals, I can help you. Another way to simplify radicals here is I like to use the prime factorization method. So the square root of 50, 2 numbers that multiply to get 50 is 2 and 25. 2 is a prime number, it's a dead end, so I'll circle it. 25, I can split that up into 5 times 5, and 5 is a prime number. Then to get the final answer, I would say I have a pair of 5s. I have a pair of 5s here. They're friends. Friends go outside and play, so they will go outside this radical. 2 has no friends. It has no friends at all. It's like Mr. Keeney in high school. It's got to stay inside. It has no friends. So that is another way you can get the answer for simplified radical form. If I lost you there, we're going to go over questions and examples in our meeting, so no worries. Another way you could do this, I mentioned there's another way, and I know I'm running out of space, but actually let me start with the highlighter. If you want this, which is what we just got, you can always go, if they provide you a picture, you can draw yourself a right triangle. That's right triangle. And when it's horizontal like this, it's very easy to get side lengths. Like for example over here, that's 1. That's 1 unit. Down here, we could even count 1, 2, 3, 4, 5, 6, 7. That's 7. So some of you guys probably see where I'm going here. That's our missing value C, we can use the Pythagorean theorem, c squared equals a squared plus b squared. So we'd have c squared equals, a and b doesn't matter, I'll sign this as a, we'll say b is this one. So that would be 1 squared plus 7 squared. And then c squared is equal to 1 plus 49. C squared is equal to 50. And then I want c, not c squared, so I'd have to square root both sides. And you'd see right here how this correlates with this right here. So we'd get the same answers for this. So it would be approximately 7.07 units. Or we could say it's exactly 5 radical 2 units. So either way works. If you have a picture, I actually sometimes prefer to do the Pythagorean theorem. It is important that you can do both, just as then it's important that you can get a decimal form or a radical form. Let's do another example. So now on this one, they do not give us a picture. Let's stick with the straight distance formula. So if I want to find the length of GH, I have GH is equal to, and I'm going to go ahead and write it down again. I know I've written it down a lot, but it's something that I want you guys to be familiar with. I want it to be something that you guys will see. Oop, I made an issue there. 1 squared. All right. And let's go ahead and label our points as well. We have x1, y1, x2, y2. And this might be a good time for you guys to pause the video and try it yourself. I'm going to go ahead and, because you can pause the video, I'm going to go ahead and keep going. So this is what you'll see me do this a lot when I have to substitute values in. I like to just put in everything I know that will not change, and then I'll substitute in those values. So for x2, x1, x2 is -3, and that will be minus x1, which is 5. Let's see, y2 is 6 minus y1, which is -1. And we are off to the races. I'm going to switch to a black now. GH is equal to -3 minus 5 is -8. So I got -8 squared. Ooh, bad squared. Plus 6 minus -1, that will turn to a positive. So 6 plus 1 is 7 squared. GH is equal to, we're running out of room, that's okay, 64. -8 squared is 64 plus 49. So GH is equal to the square root of, I'm going to just double check my math here. Yep, I was right. 113, square root of 113. And so now let's talk about final answer, because, and I'm going to move over here. We can say GH is, if I were to put this into a calculator, or I shouldn't say equal, the distance from G to H is approximately, and I'm going to put square root of 113 in a calculator, I got about 10.63. Do not forget your units. This squiggly right here, let me, I say squiggly, this means approximately because I am rounding. It is not exactly 10.63. The reason why I like radical form, so if I wanted to put GH, the distance, in an exact form, I can use radical form. Now the problem with this one is right here, is that 113, it's a prime number. So I cannot simplify that number anymore, or that radical anymore. So because of that, because the only two things that go into 1 and 113, or the only things that go into 113 is 1 and 113, I cannot simplify the radical. There's no perfect squares to pull out. So the final answer for the radical form would be 113 units. So just a final discussion about this right here. If you were to use the top one, benefits of that, 10.63, that is something that is very easy to visualize in your head. If you told someone that the distance was about 10.63 inches, feet, whatever it might be, they could very well get a very good idea. The downside is it's not exact, it's approximate. If you were to be constructing something, building something, putting something into a computer for a program per se. We won't get into specifics right now, but rounding could be a very big deal if you are not exact. On the flip side, the benefits to this, it is exact. It is exactly the square root of 113. The downside is I wouldn't know, and I'm a math teacher. If I asked you, what's the length of GH? What's the length of the wall over there? And you said, oh, it's it's exactly the square root of 113 units. I'd be like, oh, I have no idea how to visualize that in my head. So just some pros and cons of both. And then final example here, example 3, find the length of the segment, then find the coordinate of the midpoint of the segment. So distance, and I should have said this earlier, distance is always positive. If I go, let's say this is Kansas City, and this is St. Louis. If I drive to St. Louis tomorrow, that is a positive difference. That is positive miles that I drove. I drove, let's say, 300 miles. I think it's a little bit more than that. Now, when I drive back home, would it be negative miles? Did I say, oh, you know what? I drove 300 miles to Kansas City, or to St. Louis, and I drove negative 300 back. No, it's still positive. So no matter what direction you're going, no matter what we're doing in distance, it will always be positive, and you've dealt with this before. And where you've dealt with this is absolute value. So when we're dealing with distance, we're dealing with the absolute value. So if I wanted to find the distance of this segment, what I would do is I would take the two coordinates. So I would look at -3, I would look at 6, and I would say, you know what? That would be the difference, or the distance from -3 to 6. And I'm taking the absolute value. So the absolute value of -3 minus 6 is -9, which is 9 units. Now, if you are just want to check this, we could see 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, of course, is very easy to check. 9 units, so you can see that works out. Now, for the midpoint, the other thing is finding the midpoint. The midpoint is the average of those two coordinates. This isn't an exact on the coordinate plane, it's on the number line, but we can still use the same idea. So between -3 and 6, I want to find the average of those two coordinates. So find the average, the middle, I would add them together and divide by 2. So -3 plus 6 is 3, divided by 2, I can reduce that to 1.5. So this would be the midpoint. If you want to check that out as well, that would be right about here. That would be our midpoint, M for that, and we could also just put some tick marks on there to show that they're the same. All right, so that ends our 1.3 distance notes. I will talk to you guys in our class meeting about more things, more example problems, and